Question 22. Triangle RST is graphed on this set of axes below. How many square units are in the area of triangle RST? Whew. This seems like it's kind of difficult. I mean, obviously I can't count the squares in there. Well, I know that my area formula for a triangle, and if you want to check, you've always got your reference sheet. Area formula for a triangle is 1/2 of the base times the height. Now, the only issue is I need to find a base and a height. I kind of noticed something. This looks like maybe it's a right angle. Let's see if I can prove that, because that way I can get the height, right? Instead of getting some weird altitude. So let's see. Let me choose. I'll stick with red for this. The slope on this is 1, 2, 3, 4, 5, 6 up, 1, 2, 3 over. So this is rise of 6, run of 3. My slope is 6 over 3. Or my slope is, I can say, 2. For this one, the other one that I think looks like a right angle, looks perpendicular to it. This goes 1, 2, 3, 4, 5, 6 down. So my rise is 6, -6. And my run, I hope it's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Look at that. Well, so this is the same thing as -1/2. Well, notice that this red one up here, 2, I can write it as, instead of just 2, I can write it as 2 over 1. And then I see that this line, RS, is perpendicular to this black line over here, ST, because the slopes are negative reciprocals of each other. That means I have the top and bottom here. I flip the numerator and the denominator, the top and the bottom, and I add an negative sign. That means they're negative reciprocals, which tells me that they are a right angle, which is great because I can now use this red and this ST over here as my base and height for this formula. Whoa, wait a minute. I don't have this length, it's on a diagonal. I don't have this length either, it's on a diagonal. Well, you can always use the distance formula, which I hate because I don't like memorizing formulas, but you do have, well, I just drew straight up and down and straight right over there. I have a right triangle over here, and I have a right triangle over here, and I know I can use Pythagorean theorem when I have right triangles. A squared plus b squared equals c squared. Well, we already counted. This side over here is 6, this side is 3, and this is my c over here, my hypotenuse. I can do 3 squared plus 6 squared equals c squared to find this length over here. So the length of RS, I'm going to get that by 6 squared plus 3 squared equals c squared. This is 36 plus 9 equals c squared plus 9. This becomes 45 equals c squared. And let's pull out that calculator, because now I want to do the square root of c squared and the square root of 45. Shame it's not 49. It's going to be a little less than 7. And I can do the square root of 45, which is 6.7, but there's no decimals over here. So, you can always do it in the calculator and then plug it in and see what matches up with that. Or we can do it kind of the old-fashioned way, which is, all right, this root cancels with that. I have c is equal to, well, 45 I can break up into 9 times 5, and this can be broken up into root 9 times root 5, which is equal to c, and then this becomes 3 root 5 is equal to c. So that is using the roots, and that's going to kind of help us because these are in terms of roots. Now already, I'm starting to guess maybe it's the root 3, because there's, well, I'm going to multiply it by something. We'll find out soon enough. So we found that this c is, this is equal to rs. We'll keep rs in red. We'll go in blue for now. I want st. St should be equal to, well, a squared plus b squared. This over here was 6. This over here was 12. So now I've got 6 squared plus 12 squared is equal to c squared. And we'll come down over here working on this. 36 plus 144 is equal to c squared. This becomes 180. 50. Yeah, that sounds about right. As long as my 12 squared was right, which it is. 12 times 12. Yeah. So now I'm going to do the square root of 180. And again, it's not a nice number. So let's try, what about 180 divided by 4? Is that a nice number? Woo! Look at that. It sure is. So I can say, all right, I'm doing the root to both sides. That goes with that. The 180 I can rewrite though as root 45 times 4 is equal to c. Root 45, before we saw that root 45 became 3 root 5, and I also have that 4, so this becomes 3 root 5 and root 4 is equal to c. Well, root 4 is actually just 2, so then this becomes 3 root 5 times 2 is equal to c, which is 6 root 5 is equal to c over here. So now I've got 3 root 5 and 6 root 5 as my two. This is, by the way, st from the picture. Now we're not done yet, and I'm not adding things or whatever. What I'm going to do now is come back to my area formula, and I can now finally plug in area is equal to 1/2 of 3 root 5 times 6 root 5, and this becomes 3 and 6, 18 root 25 over 2, 18 root 25 over 2, which is 18 times 5 over 2, 18 times 5 divided by 2 is 45. Whew! And that is, I want to bring this in front, that is an answer that I have. Number 22, the answer is 45. There's a lot going on there, but nothing like too, I mean, I guess the crazy part is getting the negative reciprocal and then using Pythagorean theorem or distance formula. There's a lot for one question, but you can do it. Get 45.